Hello again, fellow tech enthusiasts and innovative thinkers. This is Patrick Emmons, your host of the Digital Innovation and Enterprise Podcast. Today, we're taking you on a journey through our recent summit where some of the brightest minds in the industry shared their profound insights on innovation and leadership. Our next speaker is Michelangelo D'Agostino, the VP of Machine Learning at Tegas. Michelangelo's career is marked by his exploration of large language models and their applications in financial text data. He has also held data and machine learning leadership roles at notable companies such as Cameo and ShopRunner. His presentation, Language Learning Models 101, is a masterclass on leveraging language models in today's digital landscape. Let's dive in.
So I think this talk might be a little bit different than some of the other talks I've seen today. I am a technologist at heart, and we're not really going to talk about strategy, business strategy. What I really want to do is try to walk you through a little bit of the basics of how some of these technologies behind generative AI, the buzzword of the day, of course, like how they actually work, maybe to hopefully demystify them a little bit for you and sort of define some of the terms that you might be seeing left and right with some actual examples. So I think to start, we all feel like we're living in this interesting moment right now where the hype is sort of going through the roof around AI, generative AI, large language models, et cetera. I think we've possibly started to enter the trough of disillusionment a little bit. I've gotten that vibe today from the conference where some folks are a little bit sick of it. But I wanted to put a little bit of data around it, being a data person myself. And so I went to Google search trends, which I like to do, to try to see what has the actual interest around AI been over the last, it's roughly 18 to 20 months, so not even 2 years. And basically what you see is that there's been roughly a 7-fold increase in the amount of interest in search traffic around AI. And it's really kind of driven by two things, which are not surprising, but it's kind of cool to actually see them in the data. So the first is almost exactly a year ago when ChatGPT was announced and released to the public, seemingly out of nowhere. But as you'll see in a second, that wasn't actually the case. And then second, going to another level, roughly in March or April of last year, when both GPT-4 came out, but also it wasn't really a giant spike right after that. It was sort of a crescendo of a lot of different things adding together all around that time, causing this sort of peak to a 7-fold increase. And I think like if you are not an AI person, but even if you are an AI person and you like weren't really paying attention to what was happening in natural language processing, even 18 months ago, and you kind of like fell asleep like that old fairy tale of Rip Van Winkle, and you wake up, like you start paying attention a year later, you wake up and you look around, you're like, wait, what is actually going on right now? The world feels like it's completely different. That's partly who I've tried to gear this talk towards a little bit. Like assuming you haven't been paying attention for the last couple of years and now you look around and you're like, wow, this stuff is everywhere. Like what is actually going on? That's what I would like to do in this talk, try to give you a sense of what's actually happening under the covers. So I want this to largely be conversational. So if you have questions, stick your hand up and I'm happy to answer questions like while I'm talking. Otherwise, I'm going to actually keep the talking part fairly brief, like hopefully only 20 minutes or so. And it will be a largely pictorial sprint through like the last 5 years of what's been happening in the space. And then I'll leave a bunch of time at the end for you to ask me kind of more detailed questions. So I thought, what better way to start on what is a large language model than to just ask a large language model what it is. And so if you go to ChatGPT and you ask what a large language model is, it gives you actually a pretty good definition. So a large language model is an artificial intelligence system that's been trained on vast amounts of text data to generate human-like language output. And it uses deep learning algorithms, yada, yada, yada. Well, let me highlight just kind of a few important pieces of this. So the first is that a large language model, it's an artificial intelligence system. In particular, it uses a kind of model that learns from data called a deep learning model. And if you want to go even one layer deeper, the kind of model is called a transformer. And that's only important to know because we throw this term GPT out there a lot. And actually the T in GPT stands for transformer. And all that is the particular kind of model that it is that learns from data. The second interesting thing is that it has been trained on vast amounts of text data. So that's actually the P in GPT. Instead of saying trained, we say pre-trained, which means someone's done a bunch of the work ahead of time for you. And these days, these models are actually trained on a very large percentage of all of the text on the internet go into pre-training these large language models. And then the final piece is that a thing that these models are trained to do is to generate human-like language output. And so the G is actually the G in GPT. So you put those three things together: generative, pre-trained, transformer. So it's a model that generates language. It was pre-trained on a huge chunk of the internet. And a transformer is just the technical kind of model that it is. So what is it actually being trained to do when it says generate human-like language output? The actual machine learning task is called language modeling. And so what it does is it tries to take a string of text and then actually just simply predict the next word in that sequence. So if you take the sentence, the best thing about AI is its ability to, the model's job is to predict what is the next word that comes after that. And maybe it's its ability to learn, its ability to predict, its ability to understand, et cetera. And behind the scenes, the model is assigning a probability to each one of these words that comes next to it. And all that we mean when we say that it's trained for a very long time is that it's sort of like dealing with a dog or raising a child or something like that. You punish the model if it predicts a ridiculous word here. Like, the best thing about AI is its ability to play baseball. Like, if the model tried to predict that, you sort of punish it and keep it from doing that in the future. And you reward it if it predicts something that's actually close to the answer that would have been observed in the data that it was trained on. So you do this with 1 billion words and very, very large models and many computers and for a really long time. And it starts to push these words to be like words that humans would generate in natural language. But I think, like, apart from just sort of reading this, it's kind of nice to actually see what this looks like in practice. Let's see if these videos actually work. So this is a user interface, and I've given it the sentence, pugs are the best breed of dog because. I'm a pug fan. We're getting a new pug puppy tomorrow in my house. So I thought that was a good thing to test. So what you see down here is the result of the model predicting the next word that comes in the sentence. So pugs are the best breed of dog because they, then you feed in that beginning of the sentence plus they, and the next word it predicts is are, loyal, affectionate, etc. Let me play this one more time. And you can see if you hover over the output of the model, it will show the different probability distributions of what are the possibilities it considered for the next word. So very certain that the next words are they and are, but in terms of what they are, it could have been they're friendly, they're loyal, they're small, they're intelligent, etc. And all that's happening is that the model is getting those probabilities and then randomly picking one and then continuing on the sentence from that random probability. So it's actually a pretty dumb thing. All it's really doing is predicting the next word. And even for the people that invented this stuff, it was not actually obvious how well this was really going to work. But if you think about it, like, in order to do that really well, to predict the next word in a sentence, you actually need to understand or learn a lot about the world. You need to kind of understand the rules of grammar somehow because it needs to be grammatical. You need to understand just things about the world. Like, what is a pug like? Is it large? Is it small? People don't like pugs because they're green. So somehow you're not in the process of just learning this thing that seems dumb. The model's actually picking up almost by accident all sorts of really rich information about the world that was in the training data about it. So this is actually not really a new thing. So people have been doing this for probably 5 years or so. And I put on this timeline, GPT-3, like the sort of version of GPT that ChatGPT is based on, came out in June of 2020. So basically more than 2 full years before we saw this actual explosion, people have been doing this. So what actually happened in all of this time, and why is it sort of blowing up and taking off now? And there are really 2 large innovations that were the reasons behind this. So the first is basically just size. So over time, people started training these models with more and more data. So going from training it on all of Wikipedia to literally training it on all of the text collected from the internet, plus adding private data sources, et cetera. So just the amount of things that we feed in that it can learn from have gotten bigger and bigger over time. And then second, the models themselves have just gotten bigger and bigger over time. And so the size of a model is roughly kind of a proxy for how much capacity it has to learn things about the world. And I kind of like this graph. So on the bottom, we have a timeline going from like 2018 up to 2020. And each dot on here is a large language model trained by a company. You see a bunch of Facebook logos, like here's a Microsoft logo. And then here is GPT-3. And basically what happened is that over time, people started training bigger and bigger and bigger and bigger models. And it's like, I don't really like these kinds of analogies, but in some ways it's sort of like an insect has a brain, but it's a very small brain. A dog has a larger brain. A human brain is larger. Like in some ways, you can think of that analogously. Like we're just training brains that have more and more capacity to learn. This is a different version of that same chart, except on this axis, it's a log scale, which means each tick mark is 10 times bigger than the one underneath it. And so you can see GPT-3 here. GPT-4, it reportedly had 1 trillion parameters. So it's, let's see, it's almost like 1,000 times bigger than the GPT-2 model down here. So we're just throwing more and more size and compute at the problem. That was the first big innovation. And then the second big innovation is a little technical, so there's not really much of a reason to get into it. But basically, roughly last spring, in March of 2022, researchers learned ways to make these models give outputs and answers that are more useful and pleasing and kind of aligned with what humans like to hear. So the way they did that, they took GPT-3, which was, again, came out in like 20 years ago, but was not that useful. And they found a way to have a bunch of humans like rate its output on a usefulness scale. So compare it to things that other humans wrote, compare different versions of the thing the machine output and rank them, give thumbs up, thumbs downs, ratings, etc. And they were able to use that human feedback data to sort of tweak the language model a little bit to give answers that were much more like useful or pleasing or seemed like they were actually following the instructions that you were trying to give it. So sometimes this goes by the name of instruction tuning because it helped the models learn how to follow human instructions much better. And so all of these companies that are training language models now have armies of outsourced humans whose job it is basically to read these textual outputs and figure out like how useful they are, how much they're aligned with what the model was being asked to do, et cetera. And that was really the key advance that led to ChatGPT. So 2020, we had GPT-3. Nothing really fundamentally changed until they learned how to incorporate this human feedback. And then once they did, ChatGPT came out. It was much more useful, and it sort of was the match that lit this giant explosion. And so what we found, again, these models were only supposed to predict the next word in a sentence. We trained them to follow instructions a little bit more closely. And then what we found was that they were picking up enough information to do all of these other kinds of interesting and potentially useful tasks, like answering questions, summarizing articles, translating between languages, doing arithmetic. So things they were not explicitly programmed to do in the first place, but kind of emerged in the process of ingesting all this data and learning to predict the next word. And so I think like actually anyone who tells you they understand why that has happened is actually lying. I think like most researchers who are honest with you will tell you that like we actually don't really understand why this works, which is both interesting and scary, I think a little bit, right? If you're trying to understand like how to control these things or how to open up the black box, like we don't really understand why they work, but they do seem to actually be working. And this is a table from the GPT-4 paper that came out last spring about all of the things that people tried to get GPT-4 to do that it was shockingly good at doing. And these are things like passing the bar exam for lawyers, passing the LSAT, which is the entrance exam for lawyers, SAT math scores, GRE, graduate school entrances. One of these is medical board exams, et cetera, AP exams, right? So most AP exams, right, it's getting 4s or 5s, which are better than a lot of things that humans do. 90th percentile on LSATs and bar exams, et cetera. So again, like was not actually programmed to do any of these things, but was able to do them. So I actually hadn't verified any of this myself. So I went out and I just Googled like SAT math practice exams, and I found an SAT math question. And it's basically asking you to solve a system of linear equations. So 3x plus 4y equals minus 23, 2y minus x equals minus 19. And then it's got a bunch of multiple choice answers. So what's x and what's y? And so again, I have typed this into GPT-4. And again, just in kind of this 101 vein, the thing that you type in at the beginning into one of these language models is called a prompt. It's like sort of what you're asking the model to do or the instructions that you're giving the model. And so literally all I did was copy and paste this SAT question. And then down at the very bottom, I wrote answer : and my hope is that it will complete the answer to the question. And it does spit out an answer. It says, hey, the answer is A, minus 5 minus 2, which is awesome, right? It just did it. Except it's actually the wrong answer. If you plug these into the equation, this is not actually the answer to this question. So you can call this this might just be a wrong answer. A lot of times people talk about when a model is confident in the answer it gives you as a hallucination. That term has come up a bunch today, but this is actually what it means. When the model looks like it gives you an answer that it's confident about, but it's actually wrong. My favorite examples of hallucinations are when I ask a language model to tell me about myself. So this is GPT-4, and I asked it, tell me about Michelangelo di Agostino. And it says lots of nice stuff, which is not true. I did not work at CERN, the European Organization for Nuclear Research. I did not do postdoc research at Harvard. I have not worked at Airbnb and Etsy. And I love the Art Institute of Chicago, but I have never actually taught at the Art Institute of Chicago. So in this case, right, it's just wrong. It's just a wrong answer. In this case, this is potentially more damaging. It said flattering things about me, but you can imagine other contexts where it has said libelous and pretty dangerous stuff about people. I think it's probably not an exaggeration to say this issue of hallucination is probably the largest open research question about language models right now. And there are techniques for making it less likely, techniques for reducing it, techniques for feeding in external data to make it more reliable. But again, anyone who tells you they've solved the hallucination problem in large language models is also currently today lying to you if they're a vendor or something like that. But, I think there is hope that we can make this much better, but it is definitely still a real issue. And so if you're building things on top of this, understanding this and how it impacts your own particular application is probably thing number one you should be worrying about. Okay, so that's a little bit about prompts and hallucination, but back to our SAT problem. So another term you might have heard people talk about is this term prompt engineering. And all prompt engineering means is messing with the instructions you give to the model in order to try to make it better. And so if you can see this kind of back and forth, all I did was instead of just asking it for the answer, I said, let's think step by step, which is a technique that people have invented in the last year. It's called chain of thought prompting. But instead of just asking for the answer, you're asking for it to almost show its work like a high school kid. So right, it's not a very big change, but now if I play the video, it's actually kind of amazing what happens. It is literally going to write out all of the steps of the problem. Hey, the first thing we should do is rearrange the second equation and then add them together so that we can cancel out the x and then yada, yada, yada. You can read all this stuff. But the important thing is that it gets down to the bottom and it actually gets the right answer. And if you read this carefully, at each intermediate step it's taking is actually correct. So on the one hand, this is really quite cool, right? There's a lot embedded in there that it understands, and then it ultimately does get to the final answer. On the other hand, literally all I did was this tiny little change. It's basically show your work. And why that has such a drastic change on the output and why it makes it so much more reliable, again, is probably something that people don't really understand. And so this term prompt engineering, it's interesting. It's one you'll hear people toss around a lot. And there are all these news headlines prompt engineering is going to be the hottest job of the, whatever it is, century it is, 22nd century, or prompt engineering is a totally dark art and no one really understands it. This is my favorite for those of you who are old enough to remember the movie Office Space. But I think the point that I really want to make here is that if you are going to use language models, you do to a certain extent have to understand the nuances of how you ask it to do what you want it to do and how that affects the answers that you get. And it is still currently a little bit of a black art. And whether that will still be the case in the future, whether it will get better, I don't really know. But right now it is a little bit of a black art. So I want to just talk a little bit about some of the things that language models can do and how you can play around with some of them yourself. And then I'll just sort of turn it around for questioning. So the kinds of things that people are using language models for today, I think there's a whole bucket of things that we used to be able to do in traditional machine learning in the field dealing with text, which is called natural language processing, summarizing documents, taking pieces of text and classifying them into different buckets or categories or sentiment, pulling out the names or entities mentioned in text. All those things were things we used to be able to do in machine learning. But today we can do them with these large language models much faster via an API, much more accurately in a way that you don't need a large specialized team of people to do. And so if you are a business that deals with a large volume of text, this is the kind of thing that large language models are really great at. So I don't want to be too salesy and talk a lot about my company, so I'm not going to do that unless you are actually curious. But I work at a company that makes a platform for financial investors to research companies. And so we sit on top of literally millions of pages of financial documents that usually people would sift through manually. And so in that case, we use large language models in a lot of different places just to help people more efficiently find the right parts of text that they're interested in, like summarize them, extract the things that they're interested in without literally printing out thousands and thousands of pages of text. So if you do work in a text-heavy line of business, that's the kind of thing where language models are potentially going to be impactful in the future. In a similar vein, answering questions about a large set of documents is also something language models are good at. So the gentleman before me, who is from AbbVie, I think had a bunch of really great examples of like what happens when you insert a whole bunch of scientific research papers and information about small molecules like into these knowledge bases and then give people the ability to ask questions over them. I'm like not a hype person, but I do think that that's probably going to be transformative, whether it's like right now or whether it's 5 years from now, but our ability to like natural language ask questions over huge corpuses of text data and get answers back is going to be pretty transformative. It's funny, like we talk about this as generative AI, but I'm actually like less excited about the true generative aspects of these. So by generative, I mean like people use ChatGPT to generate new ideas for things like give me 10 fun ideas for a bachelor party, or like write this ad copy creative for me, or write my 10th grade English homework or something like that. So it can do that. And perhaps some of you work in industries where you are generating so much content that it's annoying for humans to do. But I just personally am less excited about that. I think the applications that are going to be most transformative, at least for large language models, are helping humans sift through large bodies of information more quickly and more efficiently, rather than like writing the next great American novel, for example. Conversational agents, I think like that sort of in some ways falls into this question answering category, but it's also having like a long dialogue with an agent. I am personally like, I call myself agnostic about that. I think again, if you're like trying to have a conversation about a large set of documents, I think that can be potentially useful. I think like virtual people and having conversations with historical figures, I'm a little bit less interested in that, but that is obviously a thing people are doing right now. And then I think another one that we sometimes underestimate is going to be language models' ability to help humans write computer code. So I didn't talk so much about this, but like source code for computers is a language, right? It looks a lot like text. It is text. And these language models have the ability to, in the same way they learn to predict the next word in human language, they can do that with computer code as well. And in some ways they can do it even better because computer programs are very highly structured. And so already most of the developers I know are either using some assistant in an editor that helps them suggest more intelligently the next code to write, or are using like Google's generative search will write code for you. And again, it's not going to replace people who are writing code, but I think it's going to take people who already can write code and make us much more efficient. And so if you're interacting with SQL for your database, like our ability to take natural language and turn it into working code is also, I think, probably going to be very transformative. So those are a handful of the applications I am most excited about. In terms of how you can play with this yourself, I actually think one of the cool things about this field is that it's super, super, super easy for anyone to play around with this stuff. And my advice to audiences is always like, try one of these free tools and just whatever your job is or in your personal life, just use it for various things. So ChatGPT is probably the easiest thing, chat.openai.com. Claude is one of the vendor is called Anthropic. It's sort of the second largest closed source vendor in this space next to OpenAI. Their chatbot is called Claude. Again, it's also free to sign up and use. Google Bard is Google's version of this. And then Bing Chat within Bing Search also has a version of chat. And my advice would be just like play around with this and get a feel for yourself. Like give it text to summarize. I have a good friend from college and we went on a weekend to New York together and he asked ChatGPT to plan our whole travel agenda for the weekend just to get a feel for like how it worked. And that's really going to be the best way for you to understand like how does it work on my particular data sets? Where does it fall down? How could I potentially use this in a clever way? And I think that's just going to help you in the future to understand this technology. In some ways, like it's much more user-friendly than some of the machine learning stuff that came before it because its input and output is natural language. And so the bar to using it for things is really, really low.
What an awesome presentation from Michelangelo. His insights provide a valuable introduction to the world of large language models and their applications in financial data analysis. As we wrap up this episode, remember that innovation knows no boundaries and exploring new horizons is essential. Stay curious, stay inspired, and stay tuned for more groundbreaking conversations on innovation and the digital enterprise. To stay connected and explore future events and thought leaders, visit our LinkedIn page or check out our website at www.dragonspears.com/podcast. You can also find us on Apple Podcasts, Spotify, or wherever you get your podcasts.